Okay, let's have a look at this then. This section needs to do these three problems. We need to have the formula for the inverse of a matrix. We denote the inverse of a matrix by a to the minus 1. Here's the formula here. You'll notice that it's 1 over det A as part of the inverse. So this value determines whether the inverse exists because you can't divide by 0. So when the determinant is 0, then a to the minus 1 does not exist. So the det A determines whether the inverse exists. So if the det A is non-zero, then it does exist, doesn't it? Because you can divide by a non-zero number. Okay, so that's clear then, and it's implicit in the formula. The inverse is such that it has this property. And you can check that if you want to for all these three times these two matrices together, either this way around or that way around. For all these three examples, and you'll see it equals the identity matrix, which is what I should have written here. I equals. Okay, so let's have a look at B using this formula then. First of all, det B. Leading diagonal product 4 minus the trailing diagonal 6. So the det is minus 2, so the inverse exists. So B to the minus 1 then is equal to 1 over det A times, and what we do here for the formula is we swap these two, the leading diagonal around. So this is 4 and this is 1, and we flip the sign of the trailing diagonal. So this is minus 2, minus 3. Let's have a look at the next one. So det C now. Leading diagonal is minus 40. Take away the trailing diagonal, which is minus 42. So that's plus 42. So det C is 2. So C to the minus 1 exists then. And that's equal to 1 over det A, det C now, multiplied by, swap these two around, the leading diagonal entries, and flip the sign of the trailing diagonal. So this becomes 6, and this is minus 7. Okay, good. And then D, so det D then. Now, last thing, 6 minus 6 is 0, so d to the minus 1 does not exist. It has no inverse. D has no inverse.